Congratulations! You completed the Behavioral Design Pattern section. Here's a recap of all the topics we covered. We looked at all 11 behavioral design patterns from the Gang of Four and identified what each pattern does. The chain of responsibility pattern's intent is to give a list of receivers a chance to handle requests. The intent of the command pattern is to encapsulate operations as objects. The interpreter pattern's intent is to provide an interpreter for a domain-specific language. The intent of the iterator pattern is to provide sequential access to the elements of a collection without exposing its underlying representation. The mediator pattern's intent is to set up loose coupling between a group of objects by keeping them from referring each other directly. The intent of the memento pattern is to capture an object's internal state so that it can later be restored to this state. The observer pattern's intent is to define a dependency between objects so that when one object changes state, all its dependents are notified and updated automatically. The intent of the state pattern is to alter the behavior of an object when its internal state changes. The strategy pattern's intent is to define and encapsulate a family of algorithms to make them interchangeable. The intent of the template method pattern is to capture the structure of an algorithm in a template method and defer the implementation of particular substeps of the algorithm to subclasses. And finally, the visitor pattern's intent is to perform operations on the elements of an object structure. We also talked about when to implement these patterns. Implement the chain of responsibility pattern if your application architecture generates a stream of requests that must be handled by receiver objects, but there is no clear one-on-one mapping between the sender and the receiver of a request. Implement the command pattern if you want to package operations into self-contained objects and pass them between objects. Implement the interpreter pattern if you have multiple objectives that exist in a well-defined and well-understood domain, and the objectives can be expressed with a simple domain-specific language. Implement the iterator pattern if you want to sequentially access each element of a collection, and you want to hide the underlying representation of the collection. Implement the mediator pattern if you have a group of objects that need to refer to each other, but how the objects should interact is not known at compile time, or may change at runtime. Implement the memento pattern if you want to capture an object's internal state, so that the object can be returned to this state later. Implement the observer pattern if your objects can be grouped in subjects with a fluid internal state and observers that must be notified when the subjects change state. Implement the state pattern if you have an object that cycles through two or more discrete internal states, and the behavior of the object radically changes with each state transition. Implement the strategy pattern if you have a family of algorithms that you want to make interchangeable, and you want to vary the algorithms independently from the clients that use them. Implement the template method pattern if you have a group of algorithms that all consist of the same discrete steps, and the algorithms differ only in the implementation of specific substeps. And finally, implement the visitor pattern if you need to perform distinct and unrelated operations on elements in a complex data structure, and you don't want to query the type of each element before performing the operation. Okay, let's summarize these patterns one by one. So, the chain of responsibility pattern avoids strong coupling between the sender of a request and its receiver by giving a list of receivers a chance to handle the request. The pattern allows receivers to be configured dynamically at runtime, and more than one receiver can handle a request. A disadvantage of the pattern is that it increases the chance of unhandled requests, and the pattern is often combined with the composite and command patterns. The command pattern encapsulates operations as objects, and materializing commands into objects means they can be transferred, shared, stored, and otherwise instrumented or manipulated like any other object. This lets you queue, log, undo, or redo commands and defer execution. You can combine the pattern with the chain of responsibility pattern to create chains of request handlers with queuing, logging, or undo capability. You can also combine the pattern with the composite pattern to create macros. The interpreter pattern provides an interpreter for a domain-specific language, with an optional parser to build the expression tree from a language string. This provides a very compact representation for queries, commands, or business rules in the given domain, but it also masks the complexity of the problem domain from the rest of the application architecture. For very large languages, the pattern can create lots of expression objects in memory. You can combine the interpreter pattern with the state or flyweight patterns to reduce the number of objects on the heap. The iterator pattern provides sequential access to the elements of a collection without exposing its underlying representation. In .NET, iterators are called enumerators, and the framework uses interfaces instead of abstract classes. You can combine the pattern with the interpreter or composite patterns to provide sequential access to expressions and composites. And by combining the pattern with the factory method pattern, you can create custom iterators depending on external or runtime information. The mediator pattern sets up loose coupling between a group of objects by keeping them from referring to each other directly. This simplifies the map of references between participating objects, but the mediator may turn into a God object. The mediator and observer patterns are similar, but observer is more structured than mediator. This makes mediator more flexible, but also less likely to be reusable. The memento pattern lets you capture an object's internal state, so that it can later be restored to this state. This provides a generic way to capture object state and store it somewhere else. To protect the memento's internal state, you can either nest the memento class or make it internal. The observer pattern defines a dependency between objects, so that when one object changes state, all its dependents are notified and updated automatically. The pattern is flexible and scalable, and can easily deal with new types of observers, but it may lead to memory leaks. The .NET Framework implements the observer pattern with events. The state pattern lets you alter the behavior of an object when its internal state changes. This eliminates complex switch statements in the object methods, but the pattern can sometimes hang if a current state has no successor state. For very complex state diagrams with lots of individual states, you can save memory by making states singletons or flyweights. The strategy pattern defines a family of algorithms, encapsulates them, and makes them interchangeable. This completely shields clients from the implementation details of an algorithm. The pattern is often combined with the flyweight pattern to support several types of flyweights. The template method pattern lets you capture the structure of an algorithm in a template method and defer the implementation of particular sub-steps of the algorithm to subclasses. This provides a very compact way to implement a group of related algorithms. The template method pattern is very similar to the strategy pattern, but it differs in granularity. And finally, the visitor pattern allows you to perform operations on the elements of an object structure without having to perform dynamic type checks. But the disadvantage of the pattern is that it is a lot of work to add a new element type, and the pattern produces complex APIs. A common use for the pattern is to quickly partition a collection by type. Okay, are you ready for the quiz?